Welcome back to another exciting day in mathematics. Woo-hoo. Warm-up number 41 should be just about done. It was to find the measure of central tendency for 2, 7, 9, 5, and 12. Today's going to go a little faster just because we're getting through some of the formulas that we need. Okay? So, copy the agenda. Tonight's today's agenda is warm-up number 41. We're still in the middle of measures of variation. And your home plate for tonight is page 143, problem number 6. Now, if you think back to the home plate that we did 2 days ago, you did 143, page 143. One day we did odds, the other day we did evens, yes? Which means we already did number 6. However, today we're going to be introducing a couple formulas that we're going to be using for tonight. Oh yes, that's why I wrote down problem number 6 with shortcut formula. Okay. So, here's the code for the presentation, JKW8R, JKW8R, JKW8R. All right? Okay. So once again, yesterday was a day off from doing any math work. Tonight is that one. Look up number 6 using shortcut formulas. All right. So your Cornell note: I can summarize and compute the measures of variation. I can summarize and compute the measures of variation. I'll give you a moment to get set up. All right, here we go. So measure of variation, we've already been practicing this almost for 2 months in a row, right? Warm-ups, we're experts at all the components of finding the variance and finding the standard deviation and range. Okay, so I gave you guys a Fair model. By now you should know how to fill that in, yes? And we know that the 2 words that I'm looking for the definition is variance and spread, because the data is being spread out. And the 3 measures are what? Range, standard deviation, and variance. All right? So we started our journey with data measures of what kind. We're in the middle of what kind, and where are we headed? Tell your neighbor, please. All right? Help us out, Ethan Aguirre. Started with which kind? The what? Help him out, Emilio. All right. Ethan Rees. So we started with central tendencies, and we moved on to? And we're headed towards what, everyone? Position. Yes, that is correct. Come on, people. All right. Turn to the page of your formulas. You should have right now 1, 2, 3, 4, 5, 6, 7, 8, 9 formulas. Yes, the last one that you input was the standard deviation, but if we take a step back without the square root, it's the what? The variance, yes? All right. Well, check this out. Look up to the screen. You know all the components of that. Today, and by the way, what makes, or should I say, for what are we going to use these 2 formulas, being that the mean is using mu, and that we're using capital N for the number of data? Talk to your neighbor. What are we using these two formulas for if the mean is mu and the n is capital N for the number of data? What are we going to use that for? Looks like Bree's got it. Very good, Bree. All right. Alex got it. All right. All right. Looks like Angel's got it. Georgia's got it. But let's go with Jenny. Jenny. What are we going to use these for, being that this is mu and n for the number of data? It's capitalized. That is correct. These are for population. So write that next to it, which means we're missing the ones for what? Samples. So copy these. These are for samples. And look at the difference how it starts. What do you guys notice right away? The letter S, right? The letter S is going to tell us that these are for sample. That is correct. The second thing we change is the mu from mu to X bar. And then we change the n to a lowercase. But look what happens here now. I'll talk about that extra little thing that we added. Okay? Copy that. Look up, look up, look up. Just to make sure we got it. These last two that we had, I'm sorry, not these last ones, but the previous ones, they're for population, variance, and standard deviation, yes? All right. And we know the process because we've been doing the process for the past 2 months. The only thing that changes from population to sample is that the symbol changes to the letter S for sample. And the other thing that changes is the mean to X bar and divided by n minus 1, and it's low cap. Now, if you notice the n minus 1, that minus 1 we didn't have before. However, now that we're going to start dealing with data that varies from small number of data, maybe 5, 6 numbers, and going all the way up to 70 numbers, it's going to be fluctuating back and forth. In order to compensate for errors on the decimals, they do n minus 1 at the dividing by. Does that make sense? Since the data fluctuates that much. So, let's get started with our first example. Here we go. Example Q. And it reads, the number of public school teacher strikes in Pennsylvania for a random sample of school years is shown. Find the sample variance and the sample standard deviation of 9, 10, 14, 7, 8, and 3. Now, don't freak out. Basically, they're asking you to find the standard deviation. Do we know how to do that? Have I been prepping you with small numbers like this on the warm-ups? Yes, Mr. Q, we know the process. All right. However, look up to the screen. What does it say here? Sample variance and sample standard deviation. So, without looking at your notes, talk to your neighbor and see if they remember how to write the formula for sample variance. Sample variance. All right. And notice we've been, since I've given you plenty of practice, now you know each component. The sigma, parentheses, x minus x bar, squared, don't forget the squared, divided by n only, no, low cap n minus 1. There it is. And of course, if I ask you for the standard deviation, all we have to do is take the square root of that. So let's do this one together just to make sure we got it. Right, Alex? Bree, you guys all right over there? All right. All right, so here we go. First step, we get our data. And we start with 3, 7, 8, 9, 10, and 14. And And what do? Well, we find the mean. Do that, please. Next column, we do data minus the mean. What'd you get for the mean? Alex, go. What's that? Okay. $8.5? So that was 51 divided by 6? All right, so it's 8.5. All right, so we're going to subtract that from each of the data. And once again, I'm going over this just to make sure we got the process down and we make the appropriate changes. So that's negative 5.5, negative 1.5, negative 0.5, 0.5, 1.5, and 5.5. What do we do next? Tell you never, what do we do next with those numbers? See, make sure they got it. What do we do next? Yeah, square them. So we do x minus x mean squared. So let's square those. Squared, 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 squared. What is 5.5 squared? What is it? 30.25. 15 squared, if I can recall, is 2.25. 0.5 squared is 0.25. 0.5 squared is 0.25. 2.25 and 30.25. All right. Next, what do we do with all these numbers, guys? We find the what? Sum. So we put the sigma x minus x bar squared, and we add all of those. Let's see, calculators calculate. What is the sum of all of that? All right, sum. Let's see, Bree, what'd you get? 65.5. That is correct. Double check your computation. So now that we have the sum, what do we do with that, guys? Next. So now, be careful now, because now we're in sample. What do we do now? Divide by what? N minus 1. So there we're going to do the sum of x minus x bar squared divided by n minus 1. So you take this, 65.5, divided by n minus 1, which is, we have 6 numbers, minus 1, that's 5. So our variance for the sample is approximately did you get, Bree? $13.1. Hands, have you got that? That is correct. So that's our variance for the sample. Are we done? No, we need what? Our standard deviation, approximately. So basically we take all that and we do square root of the sum of x minus x bar squared divided by n minus 1. So what is 13.1, taking that square root, guys? 3.61. Woo-wee. You're like, it's pretty much the same, Mr. Q, just at the end we just divide by the number of numbers minus 1. From 1 to 5, how comfortable are you with this? We got this, yes? 5, 5, 5, all right. So I was just transitioning you guys from standard deviation and variance for population to now sample. All right, with that said, so that's not your home plate. Your home plate tonight, we're going to use a new formula, which is called a shortcut formula. So go back to formulas. We're going to add 2 more. And you're going to see how this same problem that we just did, it goes a lot faster with the new formulas. You're like, Mr. Hugh, how come you didn't give us those instead? Because you needed to know all the components. Let's go. So here they are. Students, shortcut formulas, students, copy those. And as you're copying them, try and understand all the symbols that you're copying to make sure that you know each part, what it means. By now you should know all the symbols. I'll give you some time to copy those. Go. All right, here we go. Look up to the screen. I'm going to go ahead and translate this to make sure you understood each part. Here it goes. It starts off by variance of what? Of sample. Yes, this means variance of sample is equal to what? The number of data times what? What does this symbol mean? The sigma or the sum of all the data squared minus the sum of all the data and then squaring it divided by the number of data times the number of data minus 1. Pretty straightforward. And of course, for the sample standard deviation, you just take the square root of that. So we're going to start off with this formula for the next example, which is the same example we just did, but now applying it to the shortcut formula. And you're going to see how it flows pretty well, because the last part, aside from substituting, is just calculating with your calculators. Ready? So, did we add these to your formulas already? So let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Hint, hint, wink, wink, study your formulas. Here we go? Yes? All right. So here, instead of this symbol, we should have the S. Is that correct? All right. So copy these data one more time. Example Super Q. Copy the data exactly as it is, please. 9, 10, 14, 7, 8, and 3. Then let's copy our shortcut formula for the variance sample. S squared equals the number of data times the sum of data squared minus, parentheses, sum of the data, and then taking that squared over n times n minus 1. I'm going to use 3 different colors to substitute values, guys. I'm going to use red, green, and blue if you have them. So I'm going to start off, look up to the screen, look up, with red. I'm going to highlight with pink in here, that represents red. And let's understand what that means. This says find the sum of the data squared. So my first data is 9. What is 9 squared? 81. 10 squared? 14 squared? 7 squared, 64, and 9. So now that we have all the data squared, what does the sigma mean? That we need to do what? Add them all. So then I want you to write over here the sum of all the data squared. So add, 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 and add. Calculators calculate. Stay focused. $4.99. Hands that got $4.99? All right, that is correct, $4.99. So we're done with that part. I'm going to switch to green. I'm going to highlight the next parentheses, this one in green. I'm going to write it over here, the sum of all data. So what is my data? What we started with over here, right? So what does that mean, sum of all that? So that means you need to add all those numbers. What'd you get, Alex? 51. Hands have got 51? That is correct. So we got those two components. What are we missing? N. What is N, everyone? The number of numbers. So how many numbers? 6. Now we can start substituting into our formula, yes? Here we go. Variance is equal to 6 times minus times squared. You said $4.99? And then minus 51, and then we're going to square that, divided by n times, what was n? 6. And what is n minus 1? 5. Yeah, so 6 minus 1 is 5. I'm just going to write the 5 there. All right, so let's finish this up. Variance is equal to, what is 6 times $4.99? That's 3,000 minus 6. That's 2,994. Minus 51 squared. What'd you get for 51 squared? 2601 over 6 times 5 is 30. Continue. Variance is 2994 minus 2600 is 393 divided by 30. We're almost done. So what is 393 divided by 30? What is it? 13.1. So we're done with our variance. There it is. This is our variance. But they want the sample standard deviation as well. So standard deviation. What do we do to find that, everyone? Approximately. Square root of this, yes? So 13.1 square root. What is it? 3.6? 3.61? Hands, have you got that? Now check this out. Look up to the screen. Look what we got for standard deviation, 3.61. But didn't we just do this number the long way earlier? What did we get? Let's see. What do you guys notice? Same thing? But instead of doing column by column by column by column by column by column, now we can actually just do the first 2 steps, substitute, and use your calculators to do the shortcut formula. From 1 to 5, how comfortable are you with the shortcut formulas? We got this, yes? So I'm going to stop the video right here. Enjoy your home play. Make sure you follow the the shortcut formulas and study your formulas. Bye. Bye.